Alright, stoichiometry. What is it and how do we use it? So, first off, what is it? Stoichiometry is used to figure out the amount of one chemical, grams, moles, etc., based on the amounts of another. So they give you the amount of one chemical in whatever unit they want to, grams, atoms, liters. They ask you to figure out the amount of another chemical based off of that using a balanced chemical equation. Either the question will give you the amount of the two or more chemicals, which are known as limiting reactant questions, which is the first type we're going to go over, or it'll tell you what the limiting reactant is and how much of it you have, and then you go from there to whatever they're looking for. Regardless of what type of question it is, we'll use the same four-step method, so our approach is not going to change based on the type of question. Let's start with the limiting reactant type question, where we need to first identify what the limiting reactant is. So, the 4 easy steps to doing limiting reactant questions. Step 1, go from grams, or whatever unit they give you, of given two chemicals to moles by dividing by the molar mass of each. So we get the molar mass in the periodic table. So what we're basically doing is going from grams to moles for each of the reactants they give us. Divide the moles of each given chemical by its coefficient from the balanced equation. Whichever chemical gives you a smaller value, so the reactant is the value you take the next step, which is step 3. And I'll explain in some more detail with actual questions. Multiply by the coefficient of chemical you're looking for. Multiply by the molar mass of chemical you're looking for. Now, the only 2 steps that are required for stoichiometry is step 2 and 3. That's always required. 1 and 4 depends on what they're giving you, what they're looking for. So, for example, if they start you with moles, you don't need to do step 1. If they're not looking for grams, you don't need to do step 4. So the only steps required is step 2 and 3. So keep that in mind. Alright, so let's look at the first type, going from grams to grams. So we have a balanced equation, 2 nitrogens plus 3 hydrogens produces 2 ammonias. So the question is, how many grams of ammonia will be produced if 14 grams of N2 reacts with 6 grams of hydrogen? Notice that they're giving a mass of 2 chemicals. One, 2, and we're trying to go to another chemical, which is the product, which is ammonia. So this is a limiting reactant question. There are 2 given amounts of chemicals. So you need all 4 steps. So step 1, go from grams of given 2 chemicals to moles by dividing by the molar mass of each. So for nitrogen, that's 28 grams in the periodic table. 0.5 moles is our value. For hydrogen, you divide by 2, which is the molar mass of H2, you get 3 moles. Alright, so step 2, divide both of these by their coefficients. So our coefficients are 2 and 3, 2 for nitrogen, 3 for hydrogen. So 0.5 moles divided by the 2 from the balanced equation, which is up here. And we get 0.25. 3 divided by 3, there's a coefficient, that's where we got the 3 from. So which one of these is smaller? 0.25, so that's the one we're going to take to step 3. So going on to step 3, we're going to multiply by the coefficient of chemical you're looking for. What are we looking for in this question? We're looking for ammonia. If we're looking for something else, we multiply by the coefficient of it. So 0.25 times the 2 moles of ammonia gives us 0.5 moles of ammonia. Now if the question was asking for moles, we're done, but it's not. We're actually asking for grams, so one more step. We're going to multiply by the molar mass of chemical you're looking for, which in this case is 17 grams per mole. So 0.5 times 17 gives us 8.5 grams, and there's our answer. So we're able to go from the limiting reactant all the way into this. So based on the limiting reactant, it's the maximum amount of ammonia that can be produced. All right, let's try another type of question. Going from moles to grams. So how many grams of ammonia will be produced if 4 moles of nitrogen reacts with 9 moles of hydrogen? Notice that I have moles for both of these, not grams, like I did in the previous question. So what's the difference? I don't need to do step 1. So you only need to do steps 2 through 4. That's because you're going from moles to grams. So first things first, there's your balance equation. We're going to divide by our coefficients, which for nitrogen is still 2. So 4 divided by 2 gives us 2. And then 9 divided by 3, which gives us 3. Notice that because I have units for both of these, the units go away. So at the end of this, I'm just left with a number. So which one of these is smaller? 2. There's our limiting reactant. Nitrogen is our limiting reactant. We're going to take that one to step 3. So for step 3, we're going to multiply by the coefficient we're looking for. We're still looking for ammonia. 2 times 2, 4 moles of ammonia. We're good. Now we need to go to grams. So multiply by the molar mass again, which is 17 grams per mole. This is 68 grams. The units, moles, go away. You yourself with 4 times 17 grams, which gives us 68 grams of ammonia. In case you're not familiar with the T-chart, that's how it functions basically. The unit you're starting with is supposed to be canceled out, which is why we put it on the bottom. All right, example 3, going from moles to moles. So what do we need to do? Well, you can kind of get the idea that step 1 is not needed for sure because we're not going to grams. Step 4 is not needed, so just step 2 and 3 only. So 8 moles of nitrogen, 6 moles of hydrogen. So first things first, divide by the coefficient, which are still our 2 and 3. So 8 divided by 2 moles of nitrogen gives us 4. 6 divided by 3 moles of hydrogen gives us 2. Which one is the limiting reactant? Hydrogen, because it's a smaller number. So we take that number to step 3. So for step 3, we're going to multiply by the coefficient which you're looking for. We're looking for ammonia. So 2 times 2 moles of ammonia is equal to 4 moles of ammonia. And we're done, because that's all the question is asking for. We don't need to go to grams. All right, example 4, going from grams to moles. So you're starting with grams, you definitely need step 1. You're ending at moles, you do not need step 4. So what steps do I need? 1, 2, and 3. So there's our 56 grams of nitrogen, there's our 20 grams of hydrogen. We're going to use that to go to moles first. So 56 divided by the molar mass, which is 28, gives us 2 moles of N2. 20 grams divided by 2, which is the molar mass of hydrogen, gives us 10 moles. Which one is smaller? Doesn't really matter, because remember, that's a step 2, not step 1. A lot of students will get in the habit of looking at this and saying, oh, 2 is my small number, I'm going to go from there. Be careful. So step 2, divide by the moles of each from the balance equation. There's 2 divided by 2 gives us 1. 10 divided by 3 gives us 3.3. Which one's smaller? There it is. That's the limiting reactant. So we take that to step 3. So in step 3, we're going to multiply by the coefficient of what we're looking for. So 1 times 2 moles of ammonia gives us 2 moles of ammonia. And we're done. All right, let's try one more question. It only gives you the amount of one chemical. So far we've dealt with the most challenging question, which is a limiting reactant. But there are questions where you do not need to worry about figuring out a limiting reactant. Do you do anything differently? Yeah, you don't have to solve for 2 different chemicals in step 1 and 2. You just do it for 1 chemical all the way through. So notice how many grams of ammonia will be produced from 7 grams of nitrogen that reacts with excess hydrogen. So they're telling you this is the limiting reactant. So they're simplifying the question for you. So as a result, I don't need to do the whole what's the limiting reactant, it really doesn't matter. So I'm going to take that 7 grams they give me, use my T-chart, divide by the 28 grams of nitrogen to get my moles. So notice just 1 chemical, not 2 chemicals like the previous examples. 2 divide by the coefficient, which is 2, 0.125. Do I need to know what a limiting reactant is? I already know. So once again, if this was a limiting reactant question, you would have 2 different values and you'd go with the one that's smaller. Step 3, multiply by the coefficient which you're looking for. Since I'm looking for ammonia, I multiply by the 2 moles, which is the coefficient again. There's 0.25. And finally, we're going to multiply by the molar mass of what I'm looking for. What am I looking for? Ammonia. Molar mass is 17, so 4.25 grams is my answer. So those are the variations for doing stoichiometry. So 4 steps. If you follow them correctly, this becomes very simple, very fast.